Imagine this. You wake up one morning to hear news that an asteroid, the size of a skyscraper, is speeding towards Earth at 25,000 miles per hour. A few hours later, the announcement hits. There's only one option left. Detonate a nuclear bomb to destroy it before it strikes. It seems simple, right? After all, it's just a rock, and we've got nuclear weapons. But the truth might shock you. What happens when the planet's fate is in the hands of a nuclear explosion aimed at something we barely understand? Let's take a deep dive into this high-stakes scenario and unravel the unknowns that could change everything. But be warned, the answers are far more complex and far more terrifying than we could have ever imagined. First, let's get a clear picture of the enemy. Asteroids are not just space debris. They're massive, fast-moving objects that have the potential to wipe out entire cities, or even civilizations. The most famous example is the asteroid that caused the extinction of the dinosaurs 66 million years ago. But that was a long time ago. Today, a similar impact could spell disaster for billions of people. So, we turn to nuclear weapons for a solution. But here's where things take an unexpected turn. The idea behind nuking an asteroid seems straightforward. Blast it with a powerful explosion and the asteroid's trajectory is altered. Simple. We could potentially save the planet by sending it off course or breaking it into smaller fragments. But what if nuking an asteroid isn't as effective as we think? What if it makes things far worse? The first problem is size. An asteroid the size of a football field, though large, is still manageable by a nuclear bomb. But what about one the size of a mountain or even larger? A nuclear explosion might only chip away at the surface, sending the rock fragments scattering in all directions. Instead of one asteroid heading toward Earth, we could end up with hundreds or even thousands of deadly pieces, each capable of inflicting catastrophic damage. But that's just the start, because what happens next is the part that could make you rethink everything. Let's take a step back. We know that when you hit an object with enough force, it breaks apart. That's simple physics. So, what if nuking the asteroid doesn't just break it into small chunks, but causes something more dangerous? What if the explosion triggers a process called spontaneous fragmentation? Here's where things get really unsettling. According to a 2015 study by planetary scientists, when certain asteroids are hit by a powerful force, the heat can cause the material inside to fracture in unexpected ways. The asteroid could explode into smaller, faster-moving fragments that are more difficult to track and, more importantly, more dangerous than the original asteroid. So instead of solving the problem, we could make it far worse. These tiny pieces might rain down on Earth, each one carrying the potential to cause widespread destruction. What if one of those pieces hits a major city, or worse, a nuclear facility? The aftermath could be even worse than the original impact. So now we have a terrifying new scenario. A solution that was meant to save us could, in reality, destroy us. But we're not done yet. Here's another twist. The problem isn't just about breaking up the asteroid. It's also about the way the explosion impacts the asteroid's core. If the asteroid is made of a dense, metallic core, a nuclear bomb might not have the effect we expect. Instead of breaking it apart, the explosion might only push the asteroid off course by a tiny fraction. And we know that in space, even a tiny deviation in asteroid's path can lead to disastrous consequences. Imagine the asteroid missing Earth by just a few miles, but instead slamming into the moon, creating massive tidal waves, or knocking out our satellite network. We've only just begun to scratch the surface of what could go wrong. But there's more. But let's back up for a moment. What if we don't even have enough time to respond with a nuclear weapon? The window of opportunity to alter an asteroid's trajectory is incredibly narrow. In some cases, we might only have months or even weeks before impact. This means we could be caught off guard by a sudden asteroid heading toward us, and by the time we realize what's happening, it's already too late to stop it with a nuclear bomb. Now think about this. We've been studying asteroids for decades, and we still don't have a foolproof way to track all the dangerous ones. Some might be too small to detect until they're nearly on top of us. Others might be camouflaged by the sun or hidden in the vastness of space, only revealing themselves when they're too close to avoid. And once we detect one, it's not like we can just launch a missile and hope for the best. It takes years of planning and resources to send a spacecraft to intercept a deadly asteroid, and by then, it might be too late. So, here's a frightening thought. what if we don't have a defense ready when the real asteroid threat shows up? What if our best options are just not enough? This isn't just hypothetical. It's a terrifying possibility that experts are actively working to avoid. So, if nuking an asteroid doesn't work and waiting for a spacecraft to divert it could take too long, what's the alternative? Could there be a solution we haven't considered yet? In fact, there is, and it's something that might sound even stranger than launching nuclear weapons at space rocks. Enter the gravity tractor, a method where we send a spacecraft to slowly alter the asteroid's path by using its gravitational pull. No explosions, no fiery destruction, just a slow, steady push. It might sound like science fiction, but early tests show that it could work if we catch the asteroid early enough. But again, it comes down to time. And right now, we don't have a proven method to stop a large asteroid if it's already on a collision course. So, where does this leave us? Do we trust nukes to save us? Or do we risk something worse happening? Should we put our faith in new, untested technologies? Or do we need to find something else entirely? The truth is, we don't know yet. The asteroid threat is real, and it's only a matter of time before we face the ultimate test. But one thing is certain: we need to start taking this seriously. The future of our planet could depend on what we do next. If we wait too long, it might be too late to stop it. Thanks for exploring in this mind-blowing topic with us. If you found this journey into the unknown fascinating, don't forget to like, share, and subscribe. We've only scratched the surface of what's out there. Stay tuned for more on the secrets of space, the threats we face, and the minding technologies that might just save us from the unthinkable.